Hey, what is going on, guys? Welcome back to another exciting episode on the channel. I hope you guys are having a fantastic day. In today's lesson, I would like to discuss the topic of something called a linked list. And this topic is actually pretty popular in the study of computer science. And in fact, if you're trying to get an internship or a full-time development job, it's highly probable that you'll be asked an interview question related to how to implement a linked list. And so in today's video, we're going to talk about how to actually implement one and what goes inside the implementation. But before we get into the nitty-gritty code, we would like to go over a simple example of why and when you would like to use a linked list, right? And so I'm going to start with the simulator on the left side here, and you can see we have the brand new Tinder course where we can swipe our images off the top of our stack, right? So we have a lot of cards and we have cards behind cards like so. And so for a linked list, what you have is a head object which points to the first item inside of your list. And so you can treat the top of your stack right here as your first item. And this item is going to have a next pointer that points to the next item in your list, which is this card back here. So we have Nancy, and I'm going to swipe her right. And then you have the next card, which is Kelly. She's 25 and she's a singer. And so when you're on Kelly, right, you're going to try to find the next card in your stack so you can maybe perform the animation like that. And then if you swipe her off, you're going to get to Lisa, which is the next pointer for the previous card of Kelly. And so what you have is a linked list with all the nodes pointing to the next object in your list. And you can keep swiping and swiping and swiping. And what happens is at the very end of your list, you have a nil pointer, or the next object points to nil, which means that you reached the end of your list. All right, so this is a very common use case for something like a linked list. And hopefully you kind of get the idea of how it works. What I would like to do now is to go into a graphic here. So let me drag this in, and maybe I'll drag myself to the bottom right to shrink me down a little bit so you can see the image. And so let's say that we have another situation where we want to use a linked list for something like Michael Jackson's best hits. And let's say this is a list of audio songs or audio tracks. And for your linked list, you have your head, which is this node right here. And this node has a value of something called Billie Jean, which is Michael Jackson's best hits at the top of the list. And then for the next node, we're going to point to the next object inside of the best hits, which is the value of Thriller, another very popular song by Michael Jackson. And then Thriller will point to the next song, which is Beat It. And then finally, the next pointer goes down to nothing, which is just nil, which means that you've reached the end of the list. And so hopefully these two brief examples help illustrate what exactly you can use a linked list for. What I want to move on to now is to actually implementing a linked list, and we're going to insert some values inside of a list using a node and also delete values as well. And so let's go ahead and jump into an Xcode Playground and do some coding right now. All right, guys, welcome to Xcode Playgrounds, which is what you're seeing on the left side of your screen right over here. Hopefully you're ready to kind of get your hands a little bit dirty with some code today. In this coding session, I'm going to show you exactly how to create a class called a linked list, and then we'll move on to discussing how to insert values into our list as well as delete. And if we have enough time, we'll talk about a special type of insert at the very end of today's video. All right, so I'm going to try to do my best job here to explain a linked list and why you would use one as opposed to something like an array. I don't guarantee that I'll do a good job, but I'll try my best. All right, so why don't we start by creating our class called a linked list. So we are going to define it using the class type instead of a struct, because a struct inside of Swift is really confusing and it makes this example really hard to follow. So let's just use a class for today's video. And for our linked list, we are going to declare one simple property inside of this guy. We're going to say var, and the head of our linked list represents the very first object in our list. And I'm going to declare it as a node optional type. If our head is nil, that means we have a completely empty list. Okay, so on the right side, we have this error now that says use of undeclared type node. What exactly does this mean? Well, we don't have this node class define. So I'm going to move on to the top section here. And let's go ahead and say class node. And let's see what goes inside of here. Well, the node is going to represent one of these guys. So we have a value and we have a next pointer. Our value, I'm going to declare my value as an integer type just to make today's example a little bit easier to follow. So let's say let value and let it be of type int, just like that. And then we also have to declare this next pointer guy that points to another node object. And at the very end, it can possibly be nil, which means that we need to use an optional. This little bit of syntax will look like this here. So I'm going to declare the next pointer as next and let it also be of type node optional. All right, so that looks pretty good. If you hit the left little play button, everything looks like it's compiling okay. And you have this error down here that says that you don't have an initializer for this node class. And if you're using a struct, you get your initializers for free, but it's a little bit different for classes. You just want to say init and declare your custom constructor little syntax here. The parameter, we're going to use value and let it be of type int. I'm going to make a second parameter here and let it be of type optional node. And during the initialization, you want to set the self.value, which refers to your instance property, to the incoming value, which is just that. Hopefully you guys are familiar with this syntax by now. We'll do the same thing for the next and just set that guy equal to next, like so. All right, the syntax is there, looks almost perfect. Running, we don't get any errors. That means everything is looking a-okay. Let's now move on to actually using our linked list somehow. What you would like to do is to say let sample list equals linked list, like that, constructed using an empty constructor. And now you have a very, very dumb linked list. You can say sample list.head. You can print this object out. I don't think you'll get anything but a nil down here. And that's exactly what we have. Okay, so right now this is a pretty useless list, right? Why don't we actually insert some objects inside of our linked list somehow? And so we really have to declare some kind of function like insert and then actually implement this thing. But if you're not familiar with how a linked list works, it's actually easier to create a sample function. So I'm going to say set up dummy nodes. And I'll set up my linked list using some dummy nodes inside of this function just so that you can kind of see what's going on a little bit better. I'm going to declare my head, so let the head be the very first item in my list. And I'm going to declare it as a node. It has that constructor that you declared right over here on line 9. And so let's say I want to create the list of 1, 2, 3, right? So let's say I want to say 1 and then 2 and then 3, and then at the very end it's going to point to nil just to represent the last object, which is nothing. All right, so what we have to do is say the head is going to be 1, and then the next node has to be this 2 node here. So I'm going to declare 2 equals node and value of 2, and then the next node has to point to the 3. And what we'll do is the same thing pretty much up here, node, and the value of 3, the next is going to be nil because the next is just nothing. Okay, so what I'm going to do now is to move on to popping this 3 into that. So let's get that highlighted, double click the 2 and put that inside of there. Okay, if I try to run now, let's say run, we'll still get the nil. And right now what I'll do is I'll say sample list dot setup dummy nodes. And if I try to run this now, you should be able to get the value of optional 1. So let's say head dot value instead, and we'll get optional 1. If you say head dot next dot value, you should get the optional 2. And then if you keep doing this by appending the next node to it, you'll get 3 and then you'll get nil. Okay. So, you can keep typing this out to figure out what exactly is inside of your list. But what you typically have to do inside of an interview room is to implement a function called display list. So let's say function and display list items. And this guy will say print out. here is what's inside of your list, and colon and the quote. And so down here, you would like to print out the entire list in sequential order, starting from the head node. I think is a pretty good idea. And so instead of using this print statement, I'm going to just comment that out. And so hopefully you guys can see what's going on down here. What I'm going to do is to say sample list dot display list items and try to hit the play. You'll get this being printed out, which means that this function is now being called correctly. And moving on here, we would like to print out everything starting from the head node. And so what you can do is you can declare some kind of while loop and then have a condition and then perform some code inside of this loop here. And I'm going to just type out the code because it's really hard to explain what the logic is without, having the code in front of you. What we're going to do is to declare this current variable here to equal the head object. And then what I'm going to do inside of this while loop is to perform the condition check of current not equal to nil. And then during the looping, I'm just going to say current equals current dot next. Okay, so this guy right here is just going to set the current node to the very first object in your list. And as you are executing the iterations of this while loop, you're simply setting the current node to the next node, which means that you're going to start at 1, advance onto the 2, you're going to execute another iteration, and then you're going to get to 3, finally advancing to the nil node at the very end. And then once you get there, this check will no longer be true, hence exiting outside of your loop. Okay, so hopefully that logic is clear. You might have to go through this in your head, no pun intended, inside of your brain a couple of times to fully understand it. And so what you are going to do inside of this while loop to print out your display is to simply say print out. Let's see, we're going to say current dot value, which is your node value. So current is your node. So this is your node up here. And then you can simply say dot value. You can get rid of that little warning there by just using the nil coalescing of 2 question marks on this optional object here. And then what you'll get is if you run this all the way at the very bottom, you'll get that the items inside of your list is just 1, 2, and 3, right? So that's exactly how the print statement works for this while loop. Hopefully this makes sense. Make sure to go through it a couple of times by yourself to fully see what exactly is going on. Okay, so now that we have the ability to print out our list, it's going to make our lives a lot easier in terms of implementing the insertion and then the deletion next. So let's move on to inserting some values inside of our linked list without having to, call this setup dummy nodes dummy function. And what I mean is I'm going to declare a function here called insert, and it's going to take in a parameter of value, and it's going to be of type integer like so. We're just going to insert some value. And let's say we want to build up this list of 1, 2, 3, and perhaps 4 and 5. What we would like to do is we want to say sample list dot insert value like that, and just pop in the 1. And then whenever we actually call this, we want to make sure that sample list display items should print out the value of 1. And so what I'm going to do inside of this insert here, maybe I'll get rid of this dummy one that we declared earlier. I'm going to say, let's see, if head, if this guy is equal to nil, that means we are in the case of the empty list. So it's always good to check if we are the empty list. If this is the case, we're simply going to declare the head equal to a brand new node, and the value is going to be that 1 value that we inserted, which is the value parameter from the method call. And let's just hit that. And the next node is nil because, we don't have any additional items. So that's what we get for the insert. And once we run this now, you'll see that we have the display list items function prints out the value of 1. All right. Now that we have our 1 inside of our list, we would like to get the value of 2 in there as well. If you run it now, you'll see that you'll still get just the value of 1 because we're only handling the case for an empty list up above inside of our insertion. We would like to, handle the case of inserting additional items like a 2 or a 3 and so on and so forth. And so how exactly do you do this, right? Well, this is also maybe a little bit tricky, and sometimes when I have to do this, I actually forget the implementation. And so we're going to declare a current object, just like what we did before up here. We're going to declare it as the head object again. All right, so the idea here is I'm going to advance to the next node continuously using another while loop. So I'm going to say while like that. I'm going to say while current dot next not equal to nil. And then I'm going to say current, and let's say current equals current dot next. Hopefully I have this correct. And by the end of this while loop here, we're going to advance to the last node inside of our list. So what I mean is at the very end right here, end of your function, you can simply say current dot next equals something. And I see I have one little mistake, and I'm going to go back to the case of the empty list and use a return right here. And this means that if we're the empty list, we'll create our head and just completely exit outside of the function using this return statement. And so all the way down here, I know that I'm at the very end of my list through the logic of this loop, which I might explain in just a little moment here. I'm going to say current.next equals node, and then I'll insert the value from the function of here, and then let's just use the next of nil. And this is going to help us insert the 1 in the case of empty lists. And then when we call insert again with the value of 2, we're going to come down here and we're going to insert the item correctly. And I'm going to pray that I've done this correctly. And so what we have now is we have the list of 1 and 2. And let's try to insert the value of 3 as well. And run again. We will now have 1, 2, and 3. Okay. So that's kind of how the insertion works. And let me try to go through what exactly this logic is doing. First, we insert our 1 value, which comes up here. And then after that, we insert the 2, right? Which means that current equals head means that we are at the node of 1. And then current.next for the node of 1, which is down here, is going to point to a nil object, because right after here, we are pretty much 1 and nil. And so what that means is we actually never execute this while loop, and current is going to equal to the head of 1. And then we just simply say, 1.next is the next node value, which is 2. So we get 1, 2. And so basically this will turn into 1 points to 2 and points to nil. And then you have the, very similar effect of inserting 3 right below there. And then finally, you can display your list items, and you get 1, 2, and 3. And so luckily, I was able to perform the actual implementation correctly. Sometimes I do get this wrong, but it's pretty easy to check what's wrong with your code if you know what's going on. And that's the insertion. And typically, what you'll be asked next is to delete an item instead of your linked list, right? So we've gotten the insertion done. Now we would like to say, how do we delete a certain value, like let's say 3 or 2, or maybe even the 1? And so what I mean is, when I make a function call, let's see, insert is there. Let's now go, so this is usually the second question, or maybe the third question of delete. And let's see, function delete, and we'll delete a value, and we'll just close it off like that. Okay, so what is going to go on with the delete? Well, we're going to say sample list.delete a value, and let's say we delete the value of 2, right? This should give us a list of 1, and then we can get to the 3, and then we'll get to the nil because we've removed the object of 2. And so let's just assume that we don't have any repetition inside of our list. That'll make this example a bit easier to follow. And the question is, how do we implement the deletion inside of this code here? So this one is the actual tricky one. And we will go inside of here. And so let me now show you how to implement the delete function right over here. The first thing I'll do is to check if the head right here, if this value is equal to the value that I want to delete. So I'm just going to specify that. If this is true, then I'm just going to simply say head equals head dot next. And so let's try to figure out what this is doing here by trying to delete the value of 1. And so deleting the value of 1 from my list of 1, 2, 3, we're going to run into this because head.value is 1, which equals to 1. And then we're going to make the head of our list point to the head.next, which is going to return us a list of 2, 3, and nil. And so let's try to see if that is actually true by removing this. And so we have insert 1, 2, 3, delete 1, and hit the play over here. We'll get 2 and 3 because we've deleted the object of 1. Okay, so hopefully that's pretty straightforward. The next part inside of this delete function is the harder one to actually understand. And why don't I type in the code? You can try to do this on your own first and see if you can come close. I'm going to declare 2 nodes. Now, in addition to this previous variable, I'm going to declare a second one called current right below it. And I'm going to set this guy equal to the head node like that. All right, so what I'm going to do inside of this little while loop that I'm going to declare right below is a couple of different things. I'm going to say while current is not equal to nil. And then I'm going to specify a second condition inside of here. So there's some condition check that I have to implement. Inside of my while loop, I'll simply say current equals, let's see, current dot next. And I believe the other line is going to be something like previous equal to the current like that. And so the other question is what exactly goes inside of these question marks and why exactly am I declaring this previous thing in the first place? Well, let's try to run through this example one more time with the deletion of 2. So I'm going to say delete, and why don't I just delete the value of 2 from our list of 1, 2, 3. And so with the list kind of like this right here, I want to know when I encounter the value of 2, I have to make sure that the previous node of 1 is going to point to the value of 3. So that's the kind of logic that I have to follow in order to make sure that the deletion is done correctly. And so that's why I'm defining this previous node on line 48. Hopefully that makes sense. And during this loop right here, what I'm doing is I'm advancing the current node using current.next. And then the previous right here, this variable will capture the previous node by saying previous equals the current. You do have to go through this a couple of times in your own brain to fully understand what's going on. The last thing I'll do is I'll perform one final check right here, which hopefully I'll be able to do correctly. And I'm going to check if the current node dot value, if this guy is equal to the value that I'm going to delete right here. I might be able to do this correctly, so let me try to set that. And maybe that's correct. It might be not equal, but I'm just going to let that guy be that. I think it's not equal. That makes more sense to me right now. And so after I'm done iterating through this loop, I'm pretty much guaranteed that previous will be the 1 and then current will hopefully be the value of 2, because the deletion value of 2 will mean that I'm going to exit out of this because current.value is 2. So what I can actually do here is I can say previous, which is the 1 in the case of deleting 2. I can say next equals the current dot next like that. And I think I'm good. This looks okay to me, and I'm just checking off screen to verify that the code is indeed correct. So, wow, yeah, this looks a little bit confusing, right? But we're going to run the example right below here by deleting the 2. And let's see, hit the run. We deleted the 2 out of our list and we get this. Let's see if we can still delete the 1. So delete 1, we get 2, 3. Let's see if we say delete 3, we get 1, 2. And so that looks pretty good. If we say sample, sample list dot delete, why don't we delete the 1 first and then delete the 3? We should have a value of 2. Finally, if we say sample list dot delete the value of 2, we should have an empty list and this should not crash, which is looking pretty good. Everything is running correctly. Okay, so that is the deletion. If you want to make sure you understand this code, do this a couple of times in your head to kind of print out what exactly is happening with your previous and current nodes. Okay, so that was definitely a mouthful. And let's kind of go over the last little item in our itinerary on the very top here. So whenever you are inside of an interview room, they're going to ask you, I think, about like 2 or 3 questions. And if you get through the couple of first softball questions of, let's see, we have display list items, you have to make sure you understand how to print out all the list items inside of your linked list. This is the easiest one. If you're not able to get this, then there's a pretty good chance that you're not going to get the job. The second little exercise is to make sure you can insert objects into your list. So make sure to understand this. This delete one is a little bit hard, but hopefully you should be able to implement this one correctly. And then the final one is sort of the bonus kicker here, the special insert, which there's a pretty good chance they'll ask you this question to really test your understanding of a linked list. And so this is the special insert, and I'll tell you exactly what it is right now. And let's see, I'm going to say function insert in order. And let's say value is that, and this guy will be integer as well. And so the point of insert in order is to make sure that you insert everything while you're checking the order of the items inside of your list. So for example, if you have 1, 2, and you have 4, and you have 5, and this points to nil. If you insert the value of 3 inside of this list here, you have to make sure that you have 1, 2, 3, 4, and 5. Okay, so that's how insert in order works. You make sure that you're checking the order of the insertion so that your list is still kind of sorted correctly. This might be called sort insertion if you want to rephrase it. And so this one is actually a little bit harder to implement, and I had to check this a couple of times on the internet for the actual solution. I don't think I want to go over exactly how that is done. So what I'll do is, perform a little good old copy and pasting cheat. And this is the answer that you want to implement for insertion in order. Okay, so now that I have that, function and this mysterious answer declared inside of my linked list, what I can do is to comment out the deletes. I'm going to insert 1, 2, 4, and 5. So sample list. And let's insert the value of 5. And then at the very end here, I want to say sample list.insert in order and pop in the value of 3. And hopefully this works out for me. We're going to get the insertion of 1, 2 at the top here. We get the 4 and 5, and then we have the insert in order of 3. So if I print out this guy, display list items, and try to run this, you'll get a better picture of what's going on. We have 1, 2, 3, or 1, 2, 4, 5 with these 4 objects. And then the second insertion will pop in the 3 right between the 2 and the 4. And that's kind of what we have for the implementation of a linked list object. Make sure that you actually understand how to do this before you go into the interview room. Now, one last thing that I would like to mention about a linked list is why exactly do we want to use a linked list in the first place instead of just a very simple object like an array, right? So let's say we have an array of objects of 1, 2, 3, and 4. That's just a sample array. And what happens if you want to insert something like the integer of 5 inside of this array, right? You would probably call the function called append and just pop in a value of 5. And this turns our array into 1, 2, 3, 4, and 5. And you probably don't notice what's happening if you've never studied computer science. What happens is the array right here actually needs to resize itself so that you can add this extra element of 5 at the very end there. And that's actually pretty resource intensive. If you have a linked list, all you have to do is to make sure that you're at the end of your linked list and you just append a new node onto it. And the amount of work that's required of your computer is actually relatively small compared to the array insertion. There are a lot of other reasons why you would want to use a linked list, but maybe we'll leave that for a later video. All right, everybody, that's going to wrap it up for today's lesson. Hopefully you enjoyed it. Make sure to let me know your thoughts and comments down in the section below. If you want to download the source code for today's playgrounds, you can find a link in the description below as well. If you want to learn more about iOS development as well as just Swift coding in general, make sure to check out the couple of courses using the links down below, such as the Tinder course over here. as well as the couple of other courses. That's going to be it for today. I will see you in the very next video. Bye bye, guys.